Okay, this is going to be a little bit of fun. I had to kind of work this out on the side, take some notes, come back. This can be cool. So what I've done, I've just added a new record right here to date name Tuesday, cashier 2, voids 9.24. So when we run our box plot on, say, Tuesday, we want to be able to pass in a predicate to these box plots and then have it run that predicate function, determine if the color needs to change based on the output of the predicate function. So we're going to say, all right, I guess showing is better than trying to explain it. So add this to your data. It shouldn't change your box plot too. Actually, it gives you that top bar. We didn't have that without that, did we? That's pretty cool. Yeah, but it takes our outliers out, but that's all right. I'll just make this like 18. And we still won't get our outlier, but that's okay. That's okay. But this cashier has 2, and everybody else only has 1. So let's go to our box plot. Let's go to our config. Let's add a predicate function, and then when we render all of our boxes down here, we'll just say let predicate result is equal to null. And if there is a predicate, we'll say predicate result equals predicate on the day data that we have, because we split that out up here. And then we can, right here, we can just console.log predicate result. Predicate result. Okay, and right now, we're not going to see anything in our log. Let me refresh this. Bring this up down here. We'll put this up here. So right now we get nothing because we don't have a predicate. So let's come over here. And inside of our box plot screen, or pages, let's say const predicate. It's going to take in some data, and it's going to do something with that data. For now, we're just going to return 1 and 5, let's say. And then on here, we're going to say predicate equals predicate. So here we get 1 and 5. So if there was some sort of result inside of our box plot, then we can return a different rect with a different fill. We'll probably just put it in the fill. But first we got to figure out how are we going to use this predicate. Alright, so the first thing we need to do is get the unique list of cashiers in this specific instance. So I can't really export uniques out of here. We had uniques here. So right now, just for intents and purposes, we're just going to copy this. And we're going to put this up here. And it is very, very unhappy at the moment. So since this is a TypeScript file, let's just create an interface to describe our data. This is going to be date name. That's a string. There's a cashier, which is a number. And there's voids, which is a number. So this is going to take in an iData array. And this new array is going to be an array of number. And I'm going to say for each, and we need to have a X key in here, because we do not have that. That's going to be cashier. And what's going on here? Oh, just ESLint right there. And what's wrong with this? Oh, we didn't reuse it. Okay, that's fine. So that looks like TypeScript is pretty happy with all of that. This one is going to take in a data, type iData array. It's not used, so pissed. So here we'll get our uniques. So now I have a list of all the unique cashiers. Now we need to figure out who's breaking the rules. First, we need to figure out what the rules are. So we're going to come up here and we'll just say const results. And results is going to be, well, we won't do that one yet. We won't do that one just yet. Let's get the number of transactions for each cashier. Const trans count equals, make a function called transactions, and it will take in some data. So we'll create our transactions function. It's going to take in some data, which is iData. And we'll make a const new array, which is going to be an array of numbers, and that's going to equal an empty array. I'll say const uniques equals unique data, and then uniques dot map. And we'll say new array dot push. And we're going to need a function that gets a count, so we'll say count data c dot length. This is going to give us, and then we're just going to return the new array. Now we need a count function. So let's make a count function. Const count. It's going to take in some data, which is going to be our iData array again. And it's going to take in a key, which is the number of the cashier. And we're just going to data.filter c.cashier is equal to our key. It's going to give us all the transactions that our cashier has. I need to spell cashier right. Thank you, TypeScript. So that's going to give us a count. So let's go look at console.log trans count. We'll make it plural. And then just so we can tell what's what. Okay, so we say somebody had 1, somebody had 2, 1, 1, 1, 1, 1. Now what we need to do is get the average. First we'll just get the average per cashier. And we can do that by bringing in the mean function that we had in our math. And we'll say mean trans counts and console.log average equals average. Okay, we can probably math.floor that. So our average is 1 per cashier. Okay, so let's just start out here, and we'll just say we need to map over our uniques. And we're going to get const count equals our count function, data, and then that cashier. getting all of this. So we probably need to say that this is just the length. Okay. So there's our counts again. And let's say if count.length is greater than the average, we'll just start out simple. Then we'll do a result.push. And we'll say cashier is C and the count is count.length. And then what we're going to need to do is come up here and make another interface. Result. It's going to have a cashier, which is a number, and a count, which is a number. And we come up with our new array, which we did not make. So we'll say const results result array equals an empty array, and then we're going to return the results. Predicate result is going to be cashier number 2. So that's cool. But if we want to make it really be an outlier, we're going to take it to the next level. We'll do that in the next video.